Before going to draw the resonating structure of carbonate ion, let us draw the loose structure of carbonate ion. But here we'll show the electrons in form of sheets with different colors. In the middle you see carbon and 3 oxygen atoms are there on 3 different sides. You know carbonic acid, H2CO3. In the middle, carbon has 4 valence electrons that can be shown by 4 sheets as shown. You see carbon has 4 electrons in its valence shell. Actually carbon has 6 electrons, but there are 4 valence electrons and shown by blue dots. Atomic number of oxygen is 8. Number of valence electrons per oxygen is 6. So each oxygen has 6 valence electrons that can be shown by sheets. You see carbon has 4 valence electrons. Each oxygen has 6 valence electrons. 1 2 3 4 5 6. This oxygen has also 6 valence electrons. Now a single bond can be formed over here. But here there is a double bond. These 2 oxygen atoms will be connected to 2 hydrogen atoms. This is the hydrogen atom with its valence electron, red colored. This is another hydrogen atom. This is another hydrogen atom with a red color valence electron. Here a single bond will be formed between this H and this O. Here also there is a single bond between this H and this O. Between this O and this C, a single bond will be formed. Between this O and this C, a single bond will be formed. And between this C and this O, a double bond will be formed. After dissociation of H2CO3, these 2 H atoms will be removed, but this H will be removed by leaving this electron over here. So this electron is taken by this oxygen, and this oxygen has now 1 2 3 4 5 6 7, means this oxygen becomes O minus. With this electron it attains octet. Similarly, this oxygen has 6 electrons in its valence shell and 1 from carbon 7, and this electron from hydrogen becomes 8. So this oxygen has minus charge because 1 extra electron will be there, and this electron will make this oxygen O minus. We'll remove these 2 hydrogen atoms. Now this is CO3 2 minus carbonate ion. CO O minus O minus. This is CO3 2 minus. Let us see the structure of carbonate ion. Let us draw different resonating structures of carbonate ion CO3 2 minus. This minus charge will form a bond over here, and this bond will be shifted this minus will form a bond, and this bond will be shifted. You see a double bond is formed over here, and this double bond becomes a single bond, and a negative charge is developed on this oxygen. Next resonating structure can be drawn by forming a double bond over here, or you can say this minus will form a bond over here, and this bond will be shifted. You see this minus will form a bond over here, and the existing pi bond will be shifted, and this oxygen will carry a negative charge, and there will be a double bond over here. This is the last resonating structure of carbonate ion. Now draw all those three resonating structures. This minus charge will form a bond over here, and this bond will be shifted. Next resonating structure will be written over here. Before writing the next resonating structure, we should draw a double-headed arrow over here. Yes, a double bond is formed over here, and this double bond becomes single bond, and this O carries negative charge. Now we'll draw the next resonating structure. Here this minus charge will form a double bond, and this existing double bond will become a single bond, and this pi bond will be shifted, and this oxygen will carry a negative charge. Before drawing the next resonating structure, a double-headed arrow will be drawn. You see, a double-headed arrow will be drawn. This minus charge will form a double bond over here, and this pi bond will be shifted. So we'll write the next resonating structure. Last resonating structure, you see, this O carries negative charge, this O carries negative charge, and a double bond is formed over here.